Good morning, third graders. Today we're on page 235 of your student journal, page 235, and our objective today is, today I will learn to identify patterns using a multiplication table. Okay, I know that's quite long, so I'll give you some time to catch it up. But what we're going to do today is it says we're going to identify patterns, and the tool that we're going to use to help us is a multiplication table. So that's our goal, is to use this multiplication table and find some patterns with it. Okay, let's look at our vocabulary. Our first two vocabulary words are just letting us know what even numbers are and odd numbers. So even are 0, 2, 4, 6, 8, 10, and we could go on and on with 12, 14, 16. So remember, even numbers have pairs. And then we have odd numbers, 1, 3, 5, 7, 9, and again, that can go on. Our next one would be 11 and 13 and 15. Okay. Our next word is the commutative property of multiplication. It says factors can be multiplied in any order and the product will remain the same. So A times B is the same as B times A. We could even put another example. We could say 5 times 2, which many of you know is 10, is the same as if I said 2 times 5, which is also 10. So that's the multiplicative property, the commutative property of multiplication, that we can switch the order. Okay, we also have the identity property of multiplication that says the product of any number multiplied 1 is that number. So C times 1 equals C. So some examples could be 9 times 1 equals 9. 3 times 1 equals 3. So I always think of the identity property as it doesn't change its identity. If you multiply something by 1, it doesn't change its identity. Okay, and then they're also reminding us about some multiplication terms. So the two numbers that you multiply are called factors, and your answer is called a product. So factor times factor equals product. Then we have a pattern is a sequence of numbers that follow a rule. A pattern is a rule. And then a statement that explains the sequence of patterns. So these two go together. Your pattern and rule go together. Okay, so I'm going to get started on my first problem, friends. And here's what I have. Here's my first problem. And it says, what happens when two even factors are multiplied together? So I'm going to stop there. It says when two even factors are multiplied together. So two even factors are multiplied together. Use the multiplication table to determine your answer. Give two examples to support your answer. Okay, so they're saying two even factors, and then they give me a multiplication table, okay, to use. So I know what are my even numbers. I'm going to actually highlight them. So my even numbers are 2, 4, 6, 8, 10, and 12. And they're saying if I multiply an even number times another even number, so 2, 4, 6, 8, 10, and 12. Okay, so let's see what happens if I multiply an even number by an even number. So the way multiplication tables work is it's where they meet. So 2 times 2 is 4. 2 times 4, where do they meet, is 8. 2 times 6 is 12. Let's jump to another one. Let's do 2 times 12 is 24. Okay, let's try something other than a 2. Let's go to 6. Maybe 6 times 4. Those are both even factors, and they meet at 24. Let's try 6 times 10. 6 times 10 meet here. Oh, let's try another one. Let's maybe try 8 times 8. 8 times 8 is 64. We could even try 12 times 4 maybe, one at the bottom. So I've tried 1, 2, 3, 4, 5, 6, 7, 8. I have 8 examples so far. What am I seeing? What do I notice? When I multiply an even factor by an even factor, look at all my products. Even, 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 even. Does that seem like a pattern, friends? Definitely. So I could say that the product will be even. So if I multiply two even factors, the product will be even. And then in my question, they also said, give two examples. So I could say, I could do two of my examples. I said 2 times 4 equaled 8. And then I also did 12 times 4 equaled 48. So those are two examples that I could give. Okay, let's look at my next problem. My next problem says, what happens when two odd factors are multiplied together? So two odd factors are multiplied together. And then it says, use the multiplication table to determine your answer. Give two examples. Okay, so now they want odd. So let me move this up so we can look, and we're going to do our odd. Well, what are my odd numbers? 1, 3, 5, 7, 9, 11. And they want me to do two odd numbers. So an odd times an odd. So 1, 3, 5, 7, 9, 11. Okay, so let's just try some. 3 times 5 is 15. Okay, 15's odd. Let's try another. 3 times 9 is 27. Oh, that's odd. Let's try another. Maybe 5 times 7. That's an odd. Ooh, let's try 7 times 3 is 21. That's odd. Let's try another 7. 7 times 9, 63. That's odd. Ooh. Let's see. 9 times 9 is 81. That's odd. Let's try 11 times 7, 77. Okay, we tried 1, 2, 3, 4, 5, 6, 7. And what do we notice about all the products? Odd, 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 odd. So I think that when we multiply two odd factors together, it seems like the product's going to be odd. So the product will be odd. And I can just choose any of my two examples that I wrote. So I had 7 times 3 equals 21, and then I also had 3 times 9 equals 27. So I could use those as my two examples. Okay, let's try some of these together. We are on page 236. 236, and here's our first problem. It says, and I'm sorry friends, I just realized I was writing that in green today instead of red. I apologize. What happens when you multiply an odd and an even factor together? Use the multiplication table to determine your answer. Give two examples to support your answer. Ooh, okay. So now they want us to multiply an odd and an even factor. So we need to choose odds and even. So that means on one side, let's do on the top all the odds. So I'm going to highlight them. You could circle them. You could highlight them. Do something. So what are our odds? 1, 3, 5, 7, 9, and 11. So we're going to multiply an odd. And we're going to multiply an odd times an even. So on this side, let's do our evens. So let's do 2, 4, 6, 8, 10, and 12. Okay, so what happens when we multiply an odd times an even? I'm not going to use the 1 because I know about the 1. So let's try another one. Let's do 2 times 3. Oh, we get a 6, which is an even. Let's try another 2. What about 2 times 9? Oh, we get 18, which is even. Let's try a 4. Let's do 4 times 5. 4 times 5, I'm getting 20. That's even. Oh, let's try a 6. Maybe 6 times 7. 6 times 7 is 42. That's another even. Let's try maybe 8 times 7. 8 times 7, 56. Let's try another 8. Maybe 8 times 11, 88. Oh my goodness. Let's try a 10. 10 times 3 is 30. Maybe let's try a 12. 12 times 5 is 60. We've tried a lot. We've tried even. We have 8 evens as our products. So I think that pretty much shows us a good pattern. I don't think if we tried others, we're going to come up with something different. So what could we say our answer is then? So if we multiply an odd and an even factor, it looks like the product will be even. And then we could choose any of our 2 examples. So I'm just going to choose maybe 4 times 5 equaled 20. And then we also had 8 times 7 equaled 56. And you could have chosen the same as me or different ones, but definitely looks like our product will be even. Okay, let's try another one. Here's our next one. It says, what happens when 2 double factors are multiplied together? Example, 2 times 2, 3 times 3, 4 times 4. Use a multiplication table to determine your answer. Okay, so this one we're going to have to do a little bit different because they want doubles. So I don't know if I'm going to necessarily highlight these. I'm just going to highlight the answers. So what happens when we do doubles? So let's see this. Okay, 1 times 1. Let's do that double. 1 times 1 is what? 1. Okay. Let's do 2 times 2. 2 times 2 is 4. Okay, let's do 3. 3 times 3 is 9. Okay, 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36, and we can keep going. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. So we did all the doubles. We've looked at all of our doubles right there. And now they're asking, what could we say about them? What do we see? Well, I think one thing we notice on the thing is the numbers double, but it creates this diagonal. We have so our answers are in a diagonal. We could say that. So we could say a few different things. So we could say that the products create a diagonal across the table. That's one pattern I see. I also see that when the odds doubled, they stayed odd. So 1 stayed odd, the double 3 stayed odd, the double. So we could also say, that that when the odd numbers doubled, the product was odd, right? So we could say 2 different things. We also, if we had room, we could say that when the even numbers doubled, so like when 8 and 8 doubled, the product was even. But I don't think we're going to have room for that, friends. And they do want 2 examples. So what examples? We could choose any. I could say 3 times 3 equals 9. And if I'm doing my odds, I could also say 7 times 7 equals 49. Okay, it's kind of neat though how it created that perfect line. Okay, third graders, you're going to be working on a few of these on your own. Okay, and have a wonderful day. Bye-bye.